This is the fifth note of Unit 4, Statistics. Specifically in this note, we'll be talking about measures of spread in data and standard deviation. So it says, what can you infer, justify, and conclude about John and Tara's test scores, which are seen below? Okay, so this is just a bit of a review here, right? So the last note we talked about mean, median, and mode. So a mean, remember, is just an average. So in order to get the average here, for John, we would add 76 plus 45 plus 83 plus 68 plus 64 and divide all of that by 5 because there's 5 numbers there. When we do that, we will get 67.2. Okay? The median, remember, that's the middle. So if we were to write these in order, 45 would be the first number, 64, 68, 76, and 83. So because there's an odd number here, we're just taking the middle, which is the third term. So the median, which is the middle, is 68. And lastly, remember the mode is if we have a score that's coming up more than once. So in this case, all of these scores are different, so we don't have a mode here for John. Okay, going over to Tara's test here. So again, the mean, it's just the average, so we're adding 67 plus 70 plus 70 plus 62 plus 62, dividing that by 5 again. So our average, or our mean, is 66.2. The median, again, we have to write these in order from lowest to highest. So we have 1, 2, 3, 4, 5. So our middle, I did not order that right. That's not right. 1, 2, 3, 4, 5. There we go. So the middle is going to be the third one, which is 67. And lastly, the mode is if we see a score coming up more than once. We can see we have 62 twice and 70 twice, so both of those would be our mode. So 62 and 70. Okay, so we know how to calculate all of these from the last note, but what do these results actually tell us? So what they're telling us is that John has a higher average, right? His mean, 67.2, is higher than 66.2. So that's the first thing it tells us. So John has a higher average. But what it's also saying is that Tara gets more consistent marks, right? Tara consistently gets usually a 62 and a 70, whereas John's marks are a lot more skewed, right? He got as low as a 45 and as high as an 83. So it also tells us that Tara's marks are more consistent. So John might be really good at some units and not so great at others, whereas Tara's generally around the same mark for every single unit. Okay, so measures of spread. So mean, median, and mode are all good ways to find the center of your data. Okay, the information is most useful when the sets of data being compared are similar. Right? We were comparing the same thing there. They were both test scores. It is also important to find out how much your data is spread out. So far we haven't been able to figure out how spread out that data is, really. All we've looked at is the average, the middle, and if anything reoccurs. So this gives a lot more insight into data sets that vary from each other. Okay, so let's look at some examples. So example 1, and I don't know if I warned you, this is a bit longer of a note, so bear with me. There's 3 pages here that we're going to look at. So example 1 says, consider the following 2 data sets with identical mean and median values. Why is this information misleading? So let's look at this first set. So we can see this is already ordered for us, right? So how many pieces of data are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there's 20 pieces of data, right? So the median you're going to have to look at 10 and 11, which is going to be 8, right? That middle value is 8. If we add all of these together and divide by 20, we're also going to get 8. Okay, if we look at this second set, where we have less data, right? We just have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, only 15 sets of data there. If we do the same thing, we add all of those together and divide by 15, we are still going to get 8 as our average. And the middle point here is also going to be 8. Okay, and we knew that from the top, right? It told us they have an identical mean and median. So why is this information misleading? And we can see those graphs on the side here as well, right? So it tells us the mean and median are misleading, which means they're not helpful, right? If they're leading us the wrong direction, that's not going to be helpful. And the reason for that is because one graph has a bell curve and the other is uniform. So this first graph here, we can see this is what we call a bell curve that I've just drawn not so greatly. Okay, so that's a curve, whereas we can see here that 3, 4, 5, 6, and 7, they all are happening 3 times, so we just have a straight line across there. Okay, so A is the bell curve and B is uniform. Calculations make them appear similar, but really they are spread out quite differently. Right? Those two graphs look nothing alike, right? We can see that for B, we have 3, 4, 5, 6, and 7 occurring all at all 3 times, whereas our A has every single one of those values occurring at a different amount of times. But if we average them out, if we find the middle, they are going to be the same. So what is something that can be done to further compare these graphs? What we can look at is the range in the data set. So the range is the difference between the highest and the lowest numbers. So for A, what we're going to do, the highest number for A was 16, and the lowest number was 0. So in order to find the range, we would do 16 subtract 0. So that range is 16, right? Which just means these values range from 0 all the way to 16. For B, our highest was 12, and our lowest was, so 12 minus 4. So our range here is 8. Okay, so we're ranging from just 12 to 4, which is 8 spots. Okay, so therefore, what does this actually mean? So therefore, B is more consistent because it has a smaller range. Okay, and we can kind of see that just by looking at the graphs, right? The distance from here to here is obviously shorter than the distance from here to here. Okay, that's all that's looking at, the range. Okay. So again, this is a long one, so bear with me. I'm just going to pull up the second page here. Oops. There we go. We're using purple. Okay, so second example. So it says, twins Toby and Moby. Sorry, I'm laughing at that name kind of. I've never heard that, Moby. They both are working at a local pizza shop. Their manager wants to reward the best employee with a raise. She looks at their data for 8 shifts. Who is more deserving of the raise? So let's just take a look at that data. So it's showing over 8 shifts, how many pizzas each of them make. So for our solution, she's going to start by finding the mean number of pizzas made by each employee as well as the range. Okay, so let's set this up. So let's deal with Toby first. So in order to find the mean, remember what we're doing is we're just finding the average. So that means we're adding up all of these numbers. So 54 plus 152 plus 180 plus 12 plus 72 plus 126 plus 104 plus 132 divided by 8. And the reason we're dividing by 8 is because there's 8 shifts. So if you do that on your calculator, you'll get that on average, Toby makes about 104 pizzas. Okay? In order to find the range, which we just learned on the last page, what we have to do is we need to take the highest, subtract the lowest. So the most amount, or the highest number of pizzas that Toby made was 180, and the lowest amount was 12. So we do 180 minus 12, and we get the range is 168. Okay, so that's for Toby. I'll change colors, and we'll do Moby. Okay, so again, the mean, we're just adding all of those numbers together and dividing by 8. So we're going to get 104. And for the range, we're going to take the most amount of pizzas that he made, which was also 180. And the smallest amount that he made was also 12. So the range there was also 168. Okay, well, that's not super helpful, right? This isn't really indicating to us that one of the twins is better than the other. They're both about the same with the information we have here, okay? Because the mean and the range of both employees are equal. So it says, what do you think is more consistent? Or who do you think is more consistent, rather? So just looking at those sets of data there, we can't really tell who's more consistent, right? They kind of have similar numbers, but they just vary per shift. So what we're going to have to do is we are going to have to calculate the standard deviation for each. So what is standard deviation? Because this is the first time we've actually heard that word. So standard deviation is the best option for measuring the spread of data. Okay, so it's our best option. Because as we can see, the measures we've used so far, they don't always work. They don't always give us an answer. So there are a couple, well, not a couple, there are 5 steps for calculating the standard deviation. So the first thing we need to do is we need to find the difference between each value and the mean. Okay, the second thing we need to do is we need to square the difference. And that difference is from step 1. So we're squaring that step 1 answer. Okay, once we've done that, we're going to add up all of our answers from step 2. And this is kind of a more difficult equation and probably the most difficult kind of part of this unit. So bear with me here. We'll get it sorted out. Okay. Step 4, we're going to divide this sum. Okay. So the sum is from step 3 by the number of values in the data set. Let's see if I can fit this in the data set. Okay, and the very last step is to take the square root of your answer from step 4. Okay, so that is dense, right? That's a lot of steps to find this standard deviation. So just make sure when we're going through this, you have that in front of you so that you can follow it. Okay, so what the actual formula is, and like I said, it is somewhat confusing, right? So underneath all of those steps, you can see that formula. So that little symbol out front stands for standard deviation. Okay. The X with a line over top means the mean. Okay. You can see that little kind of M-shaped thing. It also could be used for mean. N is the number of entries, and that kind of weird Z-looking thing stands for the sum. Okay, so like I said, this is a confusing equation, but we're going to use it on the next page, so hopefully from that you will be able to kind of understand where that's coming from. So one last page. We're working through this pretty quick. There's just a long note. Okay, and this is the last page. So we're still looking at Toby and Moby here because we still haven't figured out who should get a raise. Okay, so in order to do that, like it said on the last page, what we're going to do is we are going to figure out the standard deviation. So in order to do that, our first step was to find the difference between each value and the mean. So we know that the mean is 104, right? And we changed pages, so I'm just going to write that up here, that the mean was, I'm just going to double check, yeah. So the mean is 104. So our first step is to find the difference from each of the values, each of those values and the mean. So you can see we've already done the first line here, right? So the first shift he made 54 pizzas, and we subtracted our mean. Okay, so we're going to continue to do that. So 152, 152 subtract 104 is -2. 180 subtract 104 is 16. And of course, you could use your calculator here, right? 100, whoops, not 180. Wrote down the wrong number. 12 minus 104 is -92. Did I miss one here? Oh, you know what? I'm looking at the wrong thing. Hang on a second. This is why you should just use your calculator. These numbers are wrong. There we go. Let's try this again. Okay. So 152 minus 104 is obviously not going to be a negative number, so I should have realized that right away. 180 minus 104 is also not going to be a negative number, so that one's 76. 12 minus 104 is -92. 72 minus 104 is -32. 126 minus 104 is 22. 104 minus 104 is obviously 0. And 132 minus 104 is 28. Okay, so that is step 1. So if you want to label that on your thing, like on your page, that column that we just did there was step 1. Okay? The next step is to square the difference found in step 1. So as you can see, on that first line, we took that 150 and we moved it over here and squared it. Okay, so we're going to do the same with all of the other values. So we have 48, oops, I'm going to stick with my purple here. 48 squared is 2,304. 76 squared equals 5,776. -92, and again, that's in brackets because you want to make sure that it's in brackets on your calculator. Okay, if not, this might give you a negative answer, but it shouldn't, right? And the reason it shouldn't is because a negative times a negative always gives us a positive. -32 squared 1024. 22 squared is 484. 0 squared is just 0. And 28 squared is 784. Okay, so that was step 2 that we wrote out on the last page. Okay, where we had to square our answer from step 1. The third step is to add up all of our answers from step 2. So our third step is down here. It's this total. Okay, so we're taking all of those values, typing them into our calculator to get an answer. And this is always good to practice because we can make really simple mistakes here with our calculator, right? So typing all of those in, don't forget the 2,500 that we didn't write down. Your total should be, and maybe I'll do this in orange, 21,336. Okay, so now we've done steps 1, steps 2, step 3. Step 4 is to divide this sum by the number values in the data set. Okay, so we need to take that number, which is right here. We're finding the variance. So step 4, take that total, 21336, divide it by the number of values. So in our data set, if we count these, 1, 2, 3, 4, 5, 6, 7, 8. So we're dividing by 8. Okay, when we do that, again, you're going to type that into your calculator. You're going to get 2,667. Okay, so that is step 4, and we know there's only 5 steps, so we're just about there. The 5th step is to take the square root of our answer from step 4. So we now need to take the square root of 2,667, which is approximately 51.64. Okay, so in order for this standard deviation to be significant, we have to compare it to the other data set, right? We don't really know what that means right now without comparing it to Moby's results. So we're going to do the exact same thing with Moby's results here. Okay, so going through each of those 5 steps. So again, step 1 is to find the difference between the median and the data. So we have, remember, our median is 104, and that's what this little sign here stands for. Oh, not our median. What am I talking about? The mean, right? That's the mean. So again, we're just taking those values and subtracting. 102 minus 104, 120 minus 104, 96 minus 104. And you can see that negative numbers are allowed here, right? So make sure you're writing out that negative. Oops. Why am I always looking at the wrong thing? That just doesn't make sense. 96 minus 104. No, 86 minus 104 is negative 18. 120 minus 104. Wow, I am losing it. Sorry, guys. 12 minus 104 is negative 92. 180 minus 104 is 76. And 96 minus 104 is negative 8. Okay, so that was step 1. Remember, step 2 is to square those answers. So 0 squared is 0. Negative 2 squared, again, putting that in your calculator in brackets. 16 squared, 256. Negative 18 squared, 324. Numbers should all be positive, okay, because we're squaring it. So even if we start with a negative, once we square it, that means we're multiplying it by itself, it will become positive. Okay, step 3, remember, was to add all of those together. You should get 15,672. Step 4 is to find the variance, which just means you're taking that total that you just found and dividing it by the amount of data. So there's 8 pieces of data, so we're going to divide by 8. We get 1,959. Last step, take the square root of that number. Once we do that, we get approximately 44.26. Okay, so what does that actually mean? This is the most important part here. Okay, so we can see that Toby's standard deviation is greater than Moby's, right? So what does that mean? So I'm just going to summarize down here. So since, and instead of writing standard deviation, we usually just write SD. Since the standard deviation for Moby is less, his data is less spread out. Okay, so what if his data is less spread out? That means he is more consistent. Okay, so lower number means you're more consistent. So this means he is more consistent. So we can just finish that off by saying Moby deserves the raise, because remember that's what the question was actually asking us. Okay, so what that means is that if we were to just graph here, Moby's data is going to look more close together, right? So something like that, whereas Toby's data is going to look a lot more separated. Okay, so this one would be Moby, this one would be Toby. Okay, so again, just as like a quick summary point, and I don't really have space to do it, so we'll go up here by the date. Less standard deviation, or I guess I shouldn't say lower, I should say lower. Lower standard deviation equals more consistent. Okay, that is the main thing that you should take away from this note here. Okay, and this is the end of the 5th lesson of our 4th unit on statistics.